Okay, hello. Now we are going to find some solutions here, solve these trig equations. Just a bunch of algebra with trig mixed in. So start here with 2 sine cosine uh, theta, 2 sine theta times cosine theta plus cosine theta is equal to 0. Well, we have a common factor here. So I can factor out a cosine theta times 2 sine theta plus 1 is equal to 0. And so since I have two things multiplied together equals 0, either cosine theta is equal to 0 or 2 sine theta plus 1 is equal to 0. So do inverse cosine of both sides, and we get theta is equal to pi over 2 plus 2 pi k, and theta is equal to 3 pi over 2 plus 2 pi k. Uh, both of these solutions are on the unit circle, so these two are definitely going to count. If I add 2 pi k, it's going to take us off the unit circle, so we actually that doesn't add any extra um, solutions. So two of our solutions are pi over 2 and 3 pi over 2. Okay, so now we need to check. So theta is equal to, put a comma there. Now we need to check this one. We're going to subtract 1 from both sides, and then, so we're going to subtract 1, and so we get 2 sine theta is equal to -1. Divide both sides by 2. And we get sine theta is equal to -1/2. So we take the inverse sine of both sides. Actually, let me go ahead and jot this down so you can see my work. We're going to take the inverse sine of both sides, squeeze that in there. So that's going to give us theta is equal to, so where is sine equal to -1/2? Well, that's going to be at 5 pi over 6 plus 2 pi k. And at the other -1/2 is going to be in quadrant 3, so it's going to be 7 pi over 6 plus 2 pi k. Now, both of these are on the unit circle. Well, theta's by itself, so we can stop there, but both of these are on the unit circle. If I add 2 pi to any of them or subtract 2 pi, it's going to take the answers off. So these don't add anything to our solution set, but we can add in 5 pi over 6 and 7 pi over 6. And there are all of our solutions. If I wanted to be very proper, I'd put them in numerical order. I would do pi over 2, then 5 pi over 6, 7 pi over 6, and 3 pi over 2. But I'm not really worried about that. So moving on to question number 26. We got 4 sine theta minus 1 equals 2 sine theta plus 1. So we can start by just, let's just move some stuff around here. I got negative, let's subtract 2 sine theta from both sides to cancel out that term. And 4 minus 2 is going to be a positive 2 sine theta is equal to, oh, sorry, nope, didn't write that down right. 2 sine theta minus 1 is equal to positive 1. Now I can look at this and see this is not a quadratic at all. So I don't have to worry about setting it to 0. I can solve this the normal way. I can add 1 to both sides. So let's just add 1 to both sides. to give myself 2 sine theta is equal to 2. Divide both sides by 2, and we get sine theta is equal to 1. And there is only one spot on the unit circle where we'll take inverse sine of both sides before I get ahead of myself. And we look at our unit circle, and there's only one spot where that happens on the unit circle. So theta is equal to pi over 2 plus 2 pi k. And again, we're checking for solutions in this interval right here. Pi over 2 qualifies, so theta can be pi over 2. And then adding 2 pi obviously is going to make it bigger than 2 pi, and subtracting it's going to make it less than 0. So that is it. That is our only solution. Okay, number 27. This one is a quadratic. It is a quadratic, so we are going to have to play around with some stuff. So let's start by setting it equal to 0. We can add tangent squared to both sides, tangent squared theta. Tangent squared theta. That is going to give us 1 minus tangent squared theta is equal to 0. There are a number of ways you can proceed here. You can, move tangent back over here to make it positive. You can multiply by -1. You can do a lot of different things. I'm just going to do difference of squares. That's a perfect square. That's a perfect square. So I'm going to use difference of squares. So that is 1 plus tangent theta times 1 minus tangent theta is equal to 0. So that gives us two solutions. Either 1 plus tangent theta is equal to 0, or 1 minus tangent theta is equal to 0. One or the other. If 1, so this is case 1, case number 1, 1 plus tangent is equal to 0. So tangent theta. So tangent theta is equal to -1. Let's take I'm just going to shortcut the inverse tangent notation here. Take the inverse tangent of both sides. Theta is equal to, -1 is going to happen twice on the unit circle. It's going to happen at pi over 4. So again, this is tangent. You can either do 2 pi k and list both of them with 2 pi k, or just list one of them with pi k. So since to save on room, I'm just going to list this as plus pi k. So let's look at this. I have theta is going to be equal to, now pi over 4, that is on the unit circle. So that is great. So I have pi over 4. So when k is 0, pi over 4 works. Now if I add pi to this, so I'm going to add 4 pi over 4. If I add 4 over here, I get 5 pi over 4. 5 pi over 4 is also on the first rotation of the circle. So 5 pi over 4, that one works. And then if I add another pi, that would be 9 pi over 4, which is too much. Too much. So those are two of our solutions. Okay, case number 2. 1 minus tangent theta is equal to 0. Let's just subtract tangent from both sides, and we get 1 is equal to tangent theta. again, we can take inverse tangent of both sides. I did that one wrong. Okay. We are going to switch this out. Sorry about this, guys. I did this one wrong. This is the answer that should be for this side over here. Positive 1 is pi over 4. So let's make that positive, and we'll switch this to negative. And so we'll make that case 1 and make that case 2. Sorry about that, guys. So inverse tangents of negative 1. That is going to be 3 pi over 4. So theta is equal to 3 pi over 4 plus pi k. That's the negative 1 version. So 3 pi over 4 is on the first rotation of the unit circle, so we'll add that to our list. If I add pi, so this is essentially saying plus 4 pi to get the same common denominator. 3 plus 4 is 7. 7 pi over 4 is still less than 2 pi. 7 pi over 4 is still less than 2 pi, because 2 pi is going to be 8 pi over 4, so 7 is still less than 8. And if I add 4 more, it's going to be too big, and that is our list. And again, this one, yeah. Sorry about that, kind of mixed them up. Luckily, it works out the same for tangents, so it wasn't too bad. Number 28, sine squared theta is equal to sine theta plus 1 minus sine squared theta. So this looks like a quadratic, so let's see what happens when we move everything to one side. So let's just, well, there's only one thing over here, so let's just subtract sine squared from both sides. Sine squared theta. So that is going to give us 0 is equal to negative sine theta minus a sine theta is a negative 2 sine squared theta. That's the like term right there we can combine. Then we have a plus sine theta and a plus 1. I'm going to multiply, I'll just move everything, switch the sides, multiply everything by negative 1. So that way our leading coefficient is positive. So let's make this 2 sine squared theta minus sine squared theta minus 1 is equal to 0. So there is a number of ways that we can treat this, but it's pretty much the same as saying I need to solve, if this was, we can treat this as x squared and x if we wanted to, and then fix it later. But it's essentially the same thing. We just need to solve it, which we can do with the Pythagorean theorem, or we can do, not the Pythagorean theorem. We could do that with the quadratic formula, or we can do it by factoring. Totally up to you guys. I'm going to do I'm try a slightly more challenging way and try and factor it using the x method. So if we divide by 2, I just want to see if this will work. And if it doesn't, I'll just use the quadratic formula. Sine squared theta. So divide everything by 2. So sine squared theta minus 1/2 sine theta minus 1/2. So two numbers that multiply to be 1/2 and add to be 1/2. Yeah, I don't want to do that. Let's just say that A is equal to 2, B is equal to -1, and C is equal to -1. And so R, we have sine theta, that's our x, is equal to negative b, so negative 1, plus or minus the square root of b squared, which is negative 1, minus, make sure I'm not page here, there we go, 4a, which is 2, and c, which is negative 1, all over 2 times negative 1. So let's simplify this out a little bit. This is all going to be equal to 1 plus or minus the square root of, that's negative 1 squared is a positive 1. Negative 4 times 2 is negative 8, times negative 1 is a plus 8, all over, that's going to be 2 times negative 1, a negative 2. So now this is going to be equal to, so this just ends up being 9, which is the square root of 9 is 3, so this is 1 plus or minus 3 over 2. So 1 plus 3 is 4 over 2, and 1 minus 3 is negative 2 over 2. So we have 2 or negative 1. So sine theta is equal to 2, or sine theta is equal to negative 1. Well, if sine theta is equal to 2, this is undefined. Undefined, so there are no solutions. It cannot be greater than 1. But this one works out to be, so sine is negative 1 at 3 pi over 2. And that's the only spot that it's negative 1 on the first rotation. And then, so it's plus 2 pi k. But there is adding or subtracting that, takes that off the unit circle, takes it out of our interval. So that ends up being our only solution. Theta is equal to 3 pi over 2. If you decide to factor this with the slip and slide method, that's fine. I am not that great with the slip and slide method. I'm not confident with it, so I wanted to make sure that I got it right. If you have any questions, feel free to email me, and we'll move on to page 4.